Andrew plans to run a game called Lucky Cup for a school fundraising event. All profits go towards the school's fundraising efforts. The game consists of 3 standard dice, each placed into a red cup. The red cup is shaken, the dice rolled, and the number of 6s recorded. Let X be a random variable denoting the number of 6s rolled in a game of Lucky Cup. State the distribution of X. So we've got 3 standard dice, and so we have 3 trials. The probability of getting a 6 is 1/6. So this looks like it's a binomial distribution with 3 trials and a probability of success of 1/6. An incomplete probability distribution for X is shown in the table below. Complete the table above, providing the missing probabilities. So we can do this directly with the calculator. So let's just grab our calculator and let's just clear everything. And we'll go for binomial PDF. And the probability of getting a 1 with 3 trials, probability of success being 1/6, and that is 0.3472. Could probably put a calculator in standard for that. Let's just go to standard and try that. Doesn't like it, but anyway, 0.3472. It doesn't ask for it as fractions, and it's 3.73472 recurring. And then we want the probability of getting 2 of them, 0.0694 recurring, with just the 4 recurring. And finally, getting 3 out of 3. And that is going to be 0.00482996. And that one actually wouldn't be difficult to know that that was just 1/6 times 1/6 times 1/6, which is 1/216. Lucky Cup costs $1 to play. If a player rolls 1/6, they win $1. If they roll 2 6s, they win $2. And if they roll 3 6s, they win $3. Determine the school's expected profit or loss for each game of Lucky Cup. So if we look at the expected winnings, we'll call that Y, the school can get $1, positive 1, if the player loses. It could get 0 if the player gets $1 back. They could lose 1 if the player wins $2, and they could lose 2 if the player wins $3. And of course, we know the probabilities, they're the same ones that are in the table. Now, it would have been nice to have these as fractions. It's a bit easier. And so we could have manually calculated them, but we've got decimals, so let's just go ahead with that. So I'll use the 125/216 here because we were given that. And then I've got 0.3472 recurring. I've got 0.0694 recurring. And I've got 0.0048296 for this one here. And so we want the expectation of Y. So it's just going to be 1 times 125/216. Take away 1 times 0.0694 recurring. Take away 2 times 0.004896. And so we have 1 times 125 over 216. I'm just going to click this into decimal. And then I've got take away 0.0694444444. Take away 2 times my last answer, and that gives me 0.5. And so the expected winnings are 50 cents. Determine the probability that a player will make a profit in a game of Lucky Cup. Well, that's just the probability of the score being greater than or equal to 2. So in other words, that is going to be 0.0694 recurring plus 4.8296 times 10 to the negative 3. So on the calculator, we could just grab this number here and add it to this number here. And it gives me 0.074. Andrew wants to increase the attraction of the game by providing the opportunity for larger winnings. He modifies the rules of the game so that players only win money when 2 or more sixes are rolled, and the winnings for rolling 3 sixes is 3 times as much as the winnings for rolling 2 sixes. Each game still costs $1 to play. He estimates that he should be able to run 500 games and wants to make a profit of $200 for the school. So the expectation for the winnings now is going to be 200 out of 500 games, which is 0.4. Andrew calls this game Lucky Cup 2. Determine the winnings Andrew should set for rolling 3 sixes in Lucky Cup 2. Okay, so we've got Z. The school wins $1 if they get no sixes. It wins $1 if they get 1. If they get 2, it's going to be 1 take away the winnings they pay out. Remember, they receive 1 and they pay the winnings out. And then 3 times as much winnings when they get 3. Now, the probabilities here are the 125 over 216 still. And then we've got the 0.3472 recurring. And we've got the 0.0694 recurring. And the 0.0046. That's the number there on the calculator. And so what we have is that we need 0.4 to be equal to 1 times 125 over 216 plus 1 times 0.3472. We might use a bit more of that number, or use a fraction if you've worked it out, plus 1 take away W times 0.0694 recurring, plus 1 take 3W times 0.0046, and of course using that number on the calculator up there. And we can just solve for that, and it gives us that W is equal to 7.2. And that means that that's the winnings for 2 sixes. For 3 sixes, it's going to be 3 times that, which will be $21.60.